Lecture 2. Logical Equivalence. Consider the statement form not P or Q and the statement form not P and not Q. Below is a combined truth table for these two statements. Notice that for any truth value assigned to the statement variables P and Q, we have that not P or Q and not P and not Q have the same truth value. That is to say, not P and Q are, in this case, we say that the two statement forms are logically equivalent, written as shown below. If these two statement forms are logically equivalent, what would it mean for two statement forms to not be logically equivalent? Consider the statement form not P or Q, and this time consider it along with the statement form not P or not Q. In this case, we find that the two statement forms do not have the same truth values for every assignment of truth values to the involved statement variables P and Q. For instance, in the second row we see that for the truth value true assigned to P and false assigned to Q, we have that the statement form not P or Q is false, as in the previous slide, but the statement form not P or not Q is actually true. So, logically equivalent statement forms are statement forms that have the same truth value for any assignment of the involved statement variables. And logically equivalent statements are statements whose corresponding statement forms are logically equivalent. Recall that in the first slide we showed the logical equivalence between the statement forms not P and Q and not P and not Q. This establishes an equivalence law known as De Morgan's law. Similar to the way we established De Morgan's law, we can establish several other equivalence laws. The De Morgan's laws. De Morgan's laws govern how negation interacts with a conjunction or disjunction. The first De Morgan's law states that the negation of a conjunction is the disjunction of the negations, whilst the second states that the negation of a disjunction is the disjunction of the negations. Secondly, we have the commutative laws of conjunction and disjunction. We also have the distributive laws, which state that conjunction distributes over disjunction and disjunction distributes over conjunction, as shown in the slide. The last law we'll mention is the double negative law, which states that the negation of P is logically equivalent to simply P. So, how do we use these equivalence laws? Consider the statement form not P and Q and not Q or P, and the other statement form P or not Q and P or Q. We could use a truth table to show that these two statement forms are indeed logically equivalent. However, this would result in a rather large and cumbersome truth table. Alternatively, we could use a series of equivalence laws to move ourselves from the first statement form to the last. Let's try this approach. Starting with the first statement, we notice that we can commute the disjunction, making the first statement look a little bit more like the last. We also notice the negation of a conjunction, which we know is logically equivalent to the disjunction of the negations by De Morgan's law. Finally, we notice the negation of a negation, which is equivalent to the original statement by the double negative law.